Hi, my name is Keihan, and I'm the technical sales engineer here at the Taiyo America. And today I'm going to discuss Flex Solder Mask with you. First, I want to share some marketing information so you can understand why flexible solder mask is so important to Taiyo. Based on market research, we found that the flexible printed circuit board market will show some nice growth of over 10% from now until 2024. Also, they found that the areas of growth will be in consumer electronics that includes wearables and automotive electronics. We believe these will be growth areas for both Europe and America. On next slide, you can see regionally that most of flexible printed circuit boards are made in Asia Pacific, but Europe and North America accounts for 30% of all flexible printed circuit boards by the year 2024. On the other pie chart, you can see the major segments for flexible printed circuit, which is dominated by mobile phones that are mainly made in Asia, followed by displays at 11%. The rest is pretty much evenly spread among the other segments. We believe military, aerospace, medical, and automotive are areas of a strong interest for the North American and Euro market. Now, I'd like to introduce you to our FLEXFINER product. This is a photoimageable polyimide dry film. We designed this for high resolution, low spring back, and VTM0 UL rating. This product line is available in black and amber. On this slide, you can see punch Coverlay has its limits with accuracy and resolution. And Taiyo flexible solder mask allow for higher resolution and smaller openings. Most of you are familiar with the buildup of conventional flex circuit. You generally have the flexible solder mask over the device mounting section, and the bending section is mainly Coverlay. On this slide, you can see how FLEXFINER can cover both the device mounting section and bending section. And this slide illustrates the very thin construction with the FLEXFINER. You can achieve a thickness of 66 microns using a 15 micron FLEXFINER on top and bottom. Here we want to show you the structure of a FLEXFINER. You will have a standard 5 micron photoimageable image layer on top that provide heat resistance, surface hardness, and mechanical strength. Below is a 10 to 35 micron layer of a photoimageable adhesive. This layer provides excellent adhesion, low spring back force, and chemical resistance. And this slide provides a quick product line for our Amber series from 15 to 40 micron thickness. And this slide illustrates our product line for our black series with 15, 30, and 40 micron thicknesses. Okay. And to process FLEXFINER, it is very simple. After pre-treatment of the flex circuit board, you remove the protection film of the FLEXFINER and laminate it onto the flex circuit board. From there, you go to the exposure step with the artwork, followed by a post-exposure bake that is used to accelerate the exposure step. After that, you remove the carrier film and send it through the developer. The last step is a final cure. in a box oven with a standard thermal cycle of 150 C for 60 minutes. So this is our current options for building flexible printed circuit board with a dry film. Next. Here are 3 videos comparing the UL94 test on conventional solder mask and uncoated Kapton and the new VTM0 solder mask. The first video is conventional, and as you can see, the sample burned all the way to the clip after the first flame was applied, and therefore did not pass the test. The next video is only uncoated Kapton and should not burn. And the last video is of the new VTM0. Is of the new VTM0 solder mask. And as you can see, both the flames are quickly extinguished. Okay. My presentation is finished, and I want to thank you for spending your time learning about Taiyo's latest inflexible solder mask. Please feel free to reach out to us to learn more. Thank you.
So the topic of our discussion today is the next big thing is here. And it is here. It's been here for a while. You know it, but let's talk about it a little bit, just because we should. So the purpose of solder mask, I think we all know the purpose of solder mask. I'm not going to read this word for word. You know it. The real purpose of solder mask is to protect your circuitry. That's what it's doing. It's protecting your circuitry during the wave solder operation. All right. So we're going to go through a little bit of the history of solder mask quickly, briefly, just because that's what they pay me for. So years and years ago, we had what's called UV curable solder mask. And we would take a piece of artwork and we would shoot an image on a screen, and then we'd put the screen over the circuit board, and then we'd use a squeegee to push the ink through the screen onto the circuit board, and then we'd run it through a conveyor through a UV curing oven to cure it. Registration was very difficult. Resolution was not very good. Adhesion of UV solder mask because of the acrylic base was not always the best, but that's what we had. And then what happened is they invented something called thermally cured solder mask. This was a huge improvement because thermally cured solder mask is based with epoxy instead of acrylates. So the physical properties were much better. The adhesion to the copper was much better. We still had to use a piece of artwork. We still had to shoot an image onto a screen. We still have to push the ink through the screen onto the board. So resolution, mask on the pads is still an issue. But what happened then, you ask? In the 80s came liquid photoimageable solder mask, or what some people call LPI. LPI was an epoxy acrylate system. We had the acrylates so that it was photosensitive so we could expose it. It had the epoxy for better adhesion and thermal properties. So, but we still had to use a piece of artwork. We still had to put the ink on the board. We either screened it through a mesh, or we had a curtain coater or a spray machine. And we tack dry that. We use our piece of artwork to expose it for the registration purposes. We developed it, we cured it. So one thing we eliminated was our resolution problems. Obviously, we had nice straight sidewalls, but now we're putting the solder mask into the holes, which means we have to develop it out. So we came up with something called mask in hole, which was actually something that we had to work through as we're processing. But again, We're all able to do it. We've been doing this for years. What happened then is somebody decided, hey, if I can eliminate the piece of artwork, my resolution, my registration is going to automatically be better. So the equipment people started making laser, LDI for laser direct imaging, and DI, which is direct imaging, with either laser diodes or LED lights. What this did is we eliminated the artwork, which was great. It works great. However, we're still putting the mask on the board via screen printing, curtain coat spray. We're still putting ink in the hole, which means we have to develop the ink out of the hole. Very good. There's room for improvement. So where does that take us? That takes us to inkjet solder mask. Coverage where you need it, fully additive. We're not putting mask in the hole, ergo, we don't have to develop the mask out. We don't have to tack dry it. We don't have to expose it. We don't have to develop it. Less handling. We clean, we coat, we cure. Still no artwork. No artwork is a great thing. Artwork stretches, artwork scratches, artwork costs money. Mask in the hole, eliminate it. Again, we're not putting it in there in the first place. We don't have to get it out. So let's quickly go over the processing. So right now, you treat the board, pre-treat the board, you print the board with your solder mask, you tack dry it in an oven, you expose it with your artwork on an exposing machine, you put it through a developer to develop the unexposed mask off, and you cure the board. With an inkjet process, you pre-treat the board, you print the board, you cure the board. It's really that simple. You're saving steps, you're saving time, you're cutting down your footprint, you're cutting down on people, you're cutting costs. You're cutting costs and improving yields. That sounds like a win-win situation. So inkjet solder masking, in a word, what the head is doing is you're jetting ink onto the board, and then almost immediately there's a UV or an LED light that's passing over that ink and pinning it or tack drying it. What this allows us to do is to handle the board, turn the board over, do the second side. It is not curing the ink. It is simply pinning it. This is a nice shot of the inside of an inkjet machine. They're not very big. They're not very tall. They don't take a lot of power. They don't use a lot of air. Got a computer screen in there. You have the apparatus where the heads are to jet the ink, and you can see the circuit board sitting there waiting to be jetted. This, my friends, is a picture of a very nice solder mask defined pad using inkjet technology. I think you're all going to look at this and saying, wow, if I could do that, I'd be sold today. Well, you can do this today. And here's some more pictures of some a little bit different, but still solder mask defined pads on copper. These are nice and round. And here's a close-up of a photo. Sometimes you have defined pads where you need to maintain a min-max. Inkjet's going to allow you to do that more easily than you're doing today as well. Isolated trace. Again, with inkjet, you can put the ink where you want it. If you have high copper, you can tell the inkjet machine, let's put more ink on those traces. If you have land areas, we can put less ink on the land areas. It's, again, a win-win. 3mm dams. 3mm dams placed directly where you want them. You can control the width of your dams. You can control the height of your dams. You can control the distance of your dams side to side from the circuits that you're avoiding. And here's a nice radical version. Now you can see the width of the dam and the height. If you want the dam height higher than the copper trace, you can do that. There's not a lot you can't do with inkjet. Just another nice photo with coverage. Can't be beat. I'll give you just a few seconds to look at that and marvel at the coverage. Edge coverage, surface coverage. You got to have it all, right? Inkjet solder mask products. There's green, there's black, there's going to be other colors moving forward. There's different versions for different machines. Different machines operate slightly differently. So We've optimized masks to work on the piece of equipment that you're purchasing. Well, so the evolution of inkjet solder masks, so we started with the 01, we're now working with the 02 and 03. The next generation masks, which there will be, are going to be even more robust and have better physical properties than the current masks. At Taiyo America, we never stop inventing. We never stop improving. End user applications. Who isn't going to want inkjet solder mask? If it's better than the current solder mask offerings, why wouldn't every end user in the world want it? They're going to want it. They told us they want it. That's why we came up with it. Final properties. Final properties, as you know, very important. If we couldn't make inkjet with better final properties than what you're getting today, what would be the point? The fact is, the inkjet solder mask physical properties are second to none. You're going to love them. The OEMs are going to love them. The CMs are going to love them. I love them. They got to be good. In conclusion, inkjet solder mask, it's here. It is here. The technology is going to make you more efficient. It's going to reduce your overall cost. It's going to reduce your footprint. It's going to improve your registration yields. It's going to eliminate the mask in the holes. Why? You know the answer, because we're not putting it in there to begin with. It's going to improve the cleanliness of your manufacturing. It's going to improve your environmental, you're going to be eliminating waste streams. So I'm going to sign off now, but what I want to tell you, if you're a manufacturer or an OEM and your Taiyo America salespeople are calling you and emailing you, we don't mean to bug you. We want to help you. So really, OEMs in particular, the reason we're trying to get a hold of you is when we came up with inkjet solder mask, what we did is we're working with you. When you tell us you want something that you don't currently have, we take that back to Taiyo and we come up with it. So we're trying to update you with the latest technology and what we can do and what we need to do next. So please, if you're out west and Brian and Kate are trying to get a hold of you, give them a call, give them an email. If you're out east and Bob's calling you up, he's just trying to update you, give you the information you need. If you're in the Midwest, that's me. Call me, text me. Again, call me. I'll call you right back. We never get sick and we rarely take time off. So again, thank you for your time. I appreciate everything about it. Continue to use our products and we'll see you next time. Call me if there's anything Taiyo America can do for you. Thank you.
And hello everyone, I'm Jesse Session, the Technical Manager at Taiyo America, and I would like to introduce you to our solution to thermal management. Over the last several years, we have seen the miniaturization of PCBs, as well as higher layer counts and higher power requirements. Our fantastic sales and marketing team generated some data to illustrate the need for thermal management. On this slide, you can see that 5G and the Internet of Things is vastly growing. On the next slide, you can see that electric vehicles are growing astronomically. And lastly, you can see the expansion of micro LEDs for various display technology. So all of these new technologies create energy or heat. On this slide, you can see the new technologies and how their components create heat. From your everyday smartphone to LED lighting and the new wave of EV batteries. On this slide, you can see some of the current solution. Very bulky copper heat pipes, heat sinks, and even fan cooling. All of these take up valuable real estate. So Taiyo America developed our own thermal management solution called ThermoCool. We use some patent-pending technology to move heat out of the PCB. we can see three potential applications. First is thermocool as an underfill adhesive. As you can see, the thermocool has 50 times the thermal conductivity of a standard solder mask or adhesive. It also has some impressive physical properties, like a glass transition of 169 degrees C and a low CTE with alpha 1 of 14 parts per million and alpha 2 of 45 parts per million. Another application is using thermocool as a thermal interface material for LED assembly. As you can see in the illustration, the thermocool would be the layer between the substrate and the standard aluminum heat sink. Lastly, you can get the thermocool in a cartridge for via filling. This will allow another mode to remove heat from sensitive areas. Thermocool works excellently as a via fill option as it is 100% solid with very low shrinkage. On this slide, we present some thermal images of our conventional 2W solder heat spread. On this slide, we present some thermal images of our conventional 2-watt heat spreader solder mask and the new thermocool 10.2W. As you can see, a huge reduction in heat and more than 23 degrees C drop in temperature. So to summarize, as electronic devices continue to grow in the marketplace, shrink in size, and provide more performance, there's definitely a need for a thermal management solution. Taiyo believes the development of thermocool 10.2W, we have made a great advancement in thermal management. So I want to thank you for spending your time learning about the Taiyo thermal management solution. And if you're interested in a sample, please let us know. Once again, thank you.